Welcome to the third session of Oracle Epics at Home. My name is Salim Hilayel, and I'm a Principal Product Manager for the Application Express. In the Middle East, I am based in Abu Dhabi, the beautiful city and the capital of the United Arab Emirates. In this session, I have Andreea Munteanu, and she's going to be talking about database links versus REST-enabled SQL. Andreea is an Oracle Epics enthusiast who recently joined Porsche Engineering in Romania. Previously, she was part of the Solution Engineering Hub at Oracle, focused on developing Apex applications and also data integration solutions for both EMEA and Japan customers. Before Andreea starts, I would love to remind you that there is a feedback. It will start 10 minutes before the end of the session, and it will last 10 minutes after the session. Please make sure that you go there and provide your feedback, and you might even win a prize, an Apex prize. So the more feedbacks you get, the better chance you will win the prize. So Andreea, you may start.
Thank you very much, Salim. So as Salim mentioned, I recently joined the Porsche engineering team, and my today's topic will be a bit of an insight around DB links versus REST-enabled SQL in Apex. What does it mean, and how can we manage it inside Apex and moreover inside our autonomous databases? Few things about me. I was a solution engineer for a bit more than 3 years at Oracle. I was part of the SE Hub in Oracle Romania. My previous experience is about more or less around Oracle database developer. But that's enough about me. So just to give you a bit of a background, today's presentation will be focused on presenting some general concepts around around my topic, and then I will go through a small demo showcasing REST-enabled SQL on Autonomous. Basically, Autonomous will be our playing ground today. So to start, for those that have not tried already Autonomous database, I would like to give you a short overview around it and the main characteristics we definitely need to check out for. So the Autonomous database has the self-driving main characteristic that actually help us provision in not more than 2 minutes an instance. In the background, in behind, we actually have a RAC database based on an Exadata infrastructure. It is self-scaling. As well, it provides us the ability to create indexes automatically as well, and you are able to clone that database. Either you perform a full database clone, or you have it like metadata, but with schema but no data inside. The second important characteristic, as I mentioned, is self-securing. All the credentials are stored in a wallet, in a zip file, and there you can find the actual TNS names where you have the connection details. You have the certificates over there, and in that way, Oracle actually adds another layer of security to your database. It is self-patching, so no downtime, and the application is running continuously. There is some auditing in there because it logs failures. It also logs database structure changes, and the last but not least important feature is that it's self-repairing. So it's actually seeking for permanently for sick devices. If we are talking about hardware, and if we are talking about software, it actually tracks all kind of issues or bugs, and it protects you actually from malicious users or external ones. So I think that's more or less around the Autonomous. if you create the database, the autonomous database, you will be able to see that we have some out-of-the-box tools in there, for especially for developers like most of us, and those are SQL Developer Web, the Apex development platform, and also Oracle Rosetta services. So SQL Developer Web is very, very easy to use, and it will help us today to actually create the DB links, because in SQL Developer Web we can execute a lot of SQL and PL SQL commands. We also can monitor our database and so on. Apex, I guess that all people involved here in my presentation already know about Apex, and we have all the functionalities in the autonomous. We already have version 19.2, and hopefully soon, after 20.1 is available, is generally available, we will have it also on autonomous. For ORDs, what can you do with ORDs? Well, actually, if you have some tables and views in your database, you actually can create some REST APIs. REST APIs that can do all the requests for you. So if you want to, let's say, to delete the data, to update or insert, you can do it through your REST-enabled objects. So here we come a bit closer of our today's topic, which is DB links and the REST-enabled SQL. Actually, Apex does a really great job by allowing customers to use external data sources. So not only what is inside the database, but also what is outside the Oracle database. Yes, it's true that local data sources are best suited for Oracle Apex, but also we can play a bit with external APIs. What is an API actually? An API is a contract between client and server. So client makes a request and it gets an answer. So communication is actually both ways. If you are familiar with APIs, you can try it out for yourselves and test a bit some of the Google free APIs or LinkedIn or even Twitter. You can just create an application and test it by using, for example, web source modules. External APIs come with two concepts, REST and SOAP. REST is more like an architectural style. It's generally preferred because it leverages less bandwidth, so it's best suited for internet usage. And the SOAP is more like a protocol. If we are going to compare the two we will see that actually REST is more flexible because it allows you to work with HTTP, URLs, JSON, and XML, while SOAP is a bit restrictive and it only allows you to work with HTTP and XML. In our today's demo, I will showcase how to create a database link. A database link in Autonomous. It's a bit different from creating a database link on an on-premise database, for example. The use case is pretty simple because we are going to create a database link from one Autonomous database to another. But I will actually put a bit of extra information and let's say provide you in case you would like to know how is it like to be, let's say, a database link from one Autonomous database to other databases, even if it's on-premise or the other database cloud service. Other way to communicate with external sources is using REST-enabled SQL. This is a new feature that came with ORDS and was embedded in Apex. Came with ORDS starting with version 17.4, if I'm not mistaken, and it allows you to build a reference to a remote Oracle database. So REST-enabled SQL can be used only between two Oracle databases, either on-premise or in the cloud. So first of all, for people that are pretty new to database links, actually database link is a one-way communication path to an Oracle database server, for example. It uses SQLnet to communicate between Oracle databases and even applications. So in fact, if you have, let's say, the database that are physically distributed in different machines, SQLnet helps them to interconnect. So it's a boundary between them. And it's a must between local and remote databases. What is already known is that you have to grant some privileges to specific users in order for them to be able to create those database links. And this is actually the same thing if we are talking about on-premise databases and autonomous databases as well. Credentials that need to be used in DB links are a bit different because in autonomous, actually, we have as I mentioned when presenting the autonomous database, we have all the credentials stored in a zip file, in a wallet, actually. And from there, we only need to use cwallet.sso. Cwallet.sso actually stores all the certificates over there. And other than that, we only need to provide the username and the password for the target database, the one that we are going to use to create a database link on. More news around autonomous database and how to create database links is that we need to use two new PL SQL APIs, like packages. Those are DBMS Cloud and DBMS Cloud Admin. DBMS Cloud is actually an API that help us create credentials for our users in order to, let's say, have access to object storage. And then, it might help us also to gather statistics automatically. For the other API, like DBMS Cloud Admin, we have the option to actually create DB links. We have the ability to check on the application continuity and some information around table spaces. For us to start with, once we have the two autonomous databases in place, we will consider it one as being remote and the other one as being the local database. So we have to download the wallet file from the remote database. Once the wallet, the zip file is downloaded, we need to extract only the SSO file, the file that has SSO extension, so cWallet, because there we have the certificates. And in order for the database link to work, we would need to have that trust certificate between them. So trust the certificate, it's like a handshake between maybe two people that needs to know each other in order to add a layer of security. After we extract that file, we add it into object storage, and we need to grant access to my user, my cloud account user, in order to be able to access that object storage once I'm going to create the database link. So how should I do it? Well, actually, I need another thing. a password. So I extract my username, which is more or less Oracle Identity Cloud Service, andrea.dobrearon at oracle.com. Now it's another email address, but that was my my email address when I was in Oracle, for example. And then once you get to the user details, you can create an authentication token, and that token is actually generated one time. You can copy it and then add it into the password to create credential in order to have access to your object storage. In that object storage, you will store the wallet. And actually, once the wallet is there, you need to run another statement, another PL SQL statement, where you need to upload the file into a directory. Data pump dir is actually a predefined directory in autonomous database. If you are dealing with one database link, this is enough. But if you are dealing with multiple database links, if you are going to connect several database instances to an autonomous, for example, you will need to create a directory, a separate directory. Why is that? Because it's a good practice, and you need to store each wallet to a separate directory, so it doesn't get overwritten, and then the DB link won't work. Once the file is there, and here I'm talking about one-to-one relationship, so we are going to build only one database link. You need to go and check on that specific directory to see if the file was already uploaded. If everything is okay and this type of output is showing up, then all good. We can move forward. Now, all of the operations performed until now are done on our local database. So from our autonomous database, actually all the operations are done as an admin. In order to create our own user, for example, in SQL Developer Web, we need, and for him to be able to create database link, we need to grant the user some privileges. As I've told you, we need to grant specific privileges on DBMS Cloud and DBMS Cloud Admin. And of course, the create database link to user, and maybe if it's required, the create session, in order to be able to create a database link on that specific schema on our local database. Next step will be to be able to connect with our user, the user from the local database. We cannot do it so easily, just going and connecting as Adobe, for example. No, we need to perform an additional step, which is pretty straightforward, because we need to add only the username in uppercase and the mapping pattern, which is schema alias, and it's actually case sensitive. So once we perform the enablement of the schema, then we will be able to connect to SQL, to switch the user and connect to the that user on our local database, on our autonomous database. Part number 2 would be to create a credential to the user from the remote database, because we want to be able to have access to the data over there, meaning tables and views. Then we need to perform a create credential command, and to provide the username and the password of the user the one that exists in our remote database. Afterwards, we only need to perform create database link statement, and we can provide whatever name we would like. We need to provide the host name, which we find it in the DNS names.ora. we provide the port. In Autonomous database, we have a port range between 1521 and 1525. The service name, actually, in this case, I used ATP Andreea Medium, and the SSL server certificate, which I encountered also in my TNS names.org. So once all of these are done, we can move forward and start testing the DB link. I will do it afterwards while performing my demo. So you will be able to check that the DB link actually exists over there. Okay, that's more or less all around DB links in Autonomous. So now if you go and get a bit of a background around REST, even we are talking about REST using it on premises or in the cloud, it's basically the same thing, more or less the same thing. And I'm going to tackle here two concepts. So REST and REST-enabled SQL. REST is actually let's say more extensive approach because, as I said, it's actually more like an architecture rather than a straightforward protocol. And in Apex, we had RESTful services, so the ability to create different handlers that will allow us to get, put, or post, or even delete our data based on our main tables. Meanwhile, REST-enabled SQL actually provides the ability to perform SQL statements on a remote instance. So actually, starting with ORDS 17.4, this feature was made available. And actually, you can communicate between Oracle databases using open protocols and without using actually SQLnet, which provides you a lot of flexibility if you are talking about accessing a remote database over the internet, for example. Also, REST-enabled SQL. So Oracle Apex provides like declarative support for a lot of components. You can build an interactive report, interactive grids, fast search on REST-enabled SQL on a reference. And more than that, if you have a reference on this, you can use it at the workspace level. So only one reference for REST-enabled SQL to a remote instance, and then you can use it in all of your applications stored in that specific workspace. Of course, if you are using it inside an application and an application gets exported and imported again, you will have the reference over there. So in behind, if you are dealing with an on-premise database, you can only check if the ORDS config files file has that specific entry key. If not, you can add it manually and run ORDS again. And then all should be good to go, and you can create as many references to remote instances as you need. But in Autonomous, that is already embedded, so so you don't have to worry about it at all. Important thing to mention is actually that if one of the databases involved in this process has HTTPS enabled, the other one must have the same thing. Why is that? Because they are actually communicating through an SSL certificate. And that certificate, it is actually an agreement that actually negotiates the encryption, the authentication, and all those all those things to provide trust to the other instance in order to access all resources stored on the remote instance. For HTTP only, yes, this is feasible as well, but only if both of them have HTTP enabled. If not, if some of them has HTTPS and the other one HTTP, this won't work. So in Oracle Apex, we can access this REST-enabled SQL feature from two places. One is from the workspace utilities, and there is a list of all the utilities over there, and you can find it pretty easy and start creating the reference, or just going inside an application and going to share components, and then you will have REST-enabled SQL over there on, I guess, data sources layer. How do you call it? Because you need to have, I don't know, a sort of reference, right? To a naming convention to call it. Well, if you are using a wizard, that is pretty easy, because you only need to select whether you have a local database, whether you have a REST-enabled SQL service, or whether you have a web source. So in this case, I select the REST-enabled SQL service. He will actually provide me a drop-down list with the references already created by me in the workspace. I should pick one of them, and then I should pick actually the table or view of the one that I'm going to use in my report. Let's say I'm going to use an interactive report +4. If you can see in the second picture over here, we have a the location. So we can actually select if we have a local database, then we will perform SQL queries in just using our own tables. But if we have remote database, then we will have a reference to REST-enabled SQL. And here we have the tennis table already created. For more complex development, for using external data sources like REST-enabled SQL, but there is if after creation you go and check to see more details around the feature, you will end up to a section called Advanced, and there you have a static ID. That static ID will actually be used in let's say more complex development. Like running a PL SQL block, like running a certain procedure. As you can see in the picture, we used this static ID, and then we have let's say function that we are going to use in order to check the number of wins per country in, let's say, all the tennis tournaments. How to handle it? So you have a pretty straightforward method, I would say. Either you select the type as being the table actually, and it will get into account all the columns, or you can build your own query, select the query, automatically Apex will retrieve you all the columns, but you can select, let's say, 3 or 4 of them, perform some column transformation, for example, and even make a join. But that's another important thing. You can join the tennis table only with other table that is stored in the same remote database, same users that exist in the remote database. So if you are going to join it with a local table from our local database, you will get an error saying that the table or view does not exist. So until this point, REST-enabled SQL supports only joins between the remote, between tables that are stored on the remote database. A bit of summary, but before that, I would like to go into a bit of just to leverage the REST-enabled SQL functionality. I will go and access my cloud account. Okay, continue. Just provide my username and password. And then we will be able to access our instances. Okay, so for this exercise, I've provisioned 2 autonomous transaction processing instances. Autonomous transaction processing are mainly used for reporting. So it's let's say the autonomous database comes in 2 flavors. It comes as the autonomous data warehouse, and that one is used mostly for analytic workloads. And the other one, the transaction processing, is actually used for IoT, reporting, even machine learning use cases. So we have 2 always free instances. We have ATP Andreea, which is our remote database, and we have ATP Andreea REST, which is our local database. What do we need from our remote database? Well, at this point, we only need to check on the service console, on the development area. We need to get the URL, the URL that will allow us to access all the REST-enabled schema from our remote database. So just copy this URL and go back to our local database, this one, and then go back, and access the tools. Open Apex over here. We already have a user over here, a workspace created, a user as well. Insert also the password. So here we are. So what's next? Well, as I mentioned in the presentation, we can go to App Builder, Workspace Utilities, all Workspace Utilities, and here we are. We have the REST-enabled SQL services. Just click on it, and then go to Create, provide a name, REST-enabled, okay, SQL on, I don't know, let's say ATP, generic. We have the endpoint URL. Well, in this case, it is really easy to build the URL because you only need to paste the URL we've copied from the remote database. And then next step will be to provide the user that has the tennis table on the remote database. So will be click next. Obviously, we will have to add also an authentication type. We have 3 types of authentication right now in autonomous, meaning in cloud, to be more general. For this demo, we will actually use the basic authentication, which only requires you to have the username, the schema name, and the password. But if you are going to put, let's say, an additional layer of security to your application, maybe you would like to use OAuth 2 credentials. OAuth 2, it's actually type of authentication that uses, it doesn't display in clear text your password, but it uses instead a token. So the password is not moving outside the, let's say, it doesn't go further, so you only have that token to use. So the basic authentication, we will provide also a name for this, basic authentication. Okay, client ID will be the schema name, and we will have also the user. Just to verify, we need to add again the user. Let's try it again. I'm not sure I've typed it correctly, but here we go. So create. It will take a while to create the reference to the REST Enabled SQL service. And afterwards, we will go and check actually to see if the tennis table will be displayed from our reference. So the REST Enabled SQL was actually successfully executed. We have the reference. If we close this window and try to refresh the page, there we have it. Okay, just test it once again to see everything is fine. We will get hopefully a success message. So yes, the reference was created, and then we can move to our application and test it. What I'm going to show you in the test is actually how to extract the table from that reference, maybe performing an update or a create, and show you the fact that the response is actually sent in JSON format. Okay, so for example, we can take we can create a report with a form, and call it, let's say, REST enabled. Sorry, enabled report, and we can have, let's say, REST enabled SQL, and of course a model dialog. Click next. Let's also build a navigation menu entry. Right now we are on the step where we can select which data source to use, a local one, our reference, or even a web source module. But we don't have web source module. We only have two more options left. So we are going to go to the REST Enabled SQL reference. And here we have it, right? So it's taking a while until it tracks the existing objects. And then we can go here and check all the tables that are stored on our remote schema, on our remote database. So for this demo, we can pick tennis info, for example. We have the columns over here. Click next. We can pick the primary key column, but now it's not available, so we are going to manage it by database. So we are going to pick the row ID as our primary key. Click create, and the pages should be available right now. Okay, in the print screen, you've already seen the fact that we are using remote database. We have remote server. Yes, of course, actually the display changed a bit, but actually the information is still the same. So we are going to focus on tennis info. We created the report, we created the form, we've included row ID as our primary key column. We are going to use it actually like our unique key. So if we are going and see the form page, just to be on the safe side and don't have any issues whenever we are going to run a create or maybe an update, we will check on the row ID to see if it's okay, and then we can hide this one because we don't need it for the time being. And just to be sure, we will put it on query only. Save. And then we can go back to page number 4 and start running the test. So user is the same, dobre with the corresponding password. Just sign in into the application. We all have the data over here. So this is through REST. We don't have this table in our local database, and I can prove it to you. So if we are going to see object browser, then we have only local department and local employees tables. So we don't have it. That means REST Enabled SQL did his job, and we are retrieving the table from the remote database. Now, in order to see the JSON response being processed through all these REST Enabled SQL reference, and actually to see the label that REST Enabled SQL is used, we can go on the debug mode, just enable the debug mode. You will see here that the URL changes, and you have here yes, it means that you have the debug mode enabled, and to see all the information and all the log that Apex has behind the scenes when processing the request, we can go and change yes into level 9. So level 9 actually retrieves all the information you need in order to check, and it's really great to use in case you have some debugging to do, new face issues actually in general. So it will take a while because, as I said, just enabling the debug mode and going to level 9, actually that means that Apex in behind is running, all the information is tracking all the logs, all the processes, and that will take a while. But not an issue because the page will be reloaded at a certain point, and then we can let's say do an update. Okay, so let's say we take our first record and make an update. For example, the form will take a bit as well because of the level 9 debug mode. But it will open, and we can do, let's say, an update on a certain row, and afterwards we can see the results. I can take you afterwards and check it actually on the remote database to see that the change already reached the endpoint, and all of this is done through this reference, through this REST Enabled SQL reference. So we can change Wimbledon with, let's say, Roland Garros. Okay, and let's see, apply changes. It's loading, it's processing, it's getting the data out of our local database, and it's processing the response. It's actually building the JSON request and sends it to the remote database. And if we are adding the fact that we have the debug mode added, it will take a while. Okay, so seems like the page is uploading really fast. We will be able to see actually the changes. So we've, just to recap, we've updated this row. Instead of Wimbledon, now we should have a Roland Garros tournament. Sorry about that. Okay. We shall see the results in a minute, I guess. And also we can check the view debug from the bottom of the page. Okay, since the reload is taking a while, we can go back to our presentation. And here I would like to emphasize what can we do and what we cannot do with our main ways to deal with external data sources. So we have DB links. This actually DB links has the option to perform joins with both remote tables and local tables. The main way of communication is through SQLnet. That gives us some insight around the data transfer. So it's dealing with binary data. On the other side, REST-enabled SQL is not able to perform joins on a remote table plus one local table. But as a plus, REST-enabled SQL actually works with HTTP and HTTPS protocols. And all the data that is processed from the local to the remote instance is done through JSON requests. And JSON response is sent from the local to the remote database. Let's say if you are dealing with large amounts of data, then maybe you should consider using DB links. But if you are dealing with a database, a remote database over the internet, then SQLnet won't go through the firewall and you would need to use REST-enabled SQL. Other use cases would be, let's say for us developers, it's a bit hard to ask for permission each time to our DBAs to grant privileges to use something like DB links. If we are allowed to use REST-enabled SQL, that will make our life easier. And we won't be annoying anymore the DBAs, or at least as not often as we did in the past. Okay, so going back to our page. Okay, so we have already the row updated. We can go to debug mode and check the latest execution. If I think you are able to see it. Yes, we have it here, level 8, 9. We are going to check the level 9 because we will check how the JSON request is built on this plan. Okay, so here we have the way that JSON request is built from local, and it's going to our remote database. Here we have the label saying that Apex using REST-enabled SQL reference. So after the change is done, the change should be also in our remote database. Okay, so let's check it. Let's go back to our remote database and check if the update is really there. Just close additional windows. Okay, go here. We have the same user, but this one is on the remote database. So we have different databases, different users. Okay, and if we're going to Object Browser, you will see here the tennis info. This is the table stored in the remote database. Plus, if we want to see the changes, we have that ID for the row I've changed 384, if I'm not mistaken. Then we will go here and check if that record was actually updated. And it was. So the process was successfully. Okay. Going back to our local database, I would like to show you the fact that the REST-enabled SQL really throws an error if it's used inside, let's say, if it's joining a local table and a remote one.
Probably this the last step, Andrea. We're running out of time.
Yes, this is the last step, and it should be done.
Yeah, okay. Yeah. Because we have many questions.
Oh, yes. That's very good. Mm-hmm. Okay, so let's create a report. We are not going to use tennis anymore. We are going to use those sample tables like AMP and department tables. So create in no time a report, an interactive maybe, and say test as well. REST-enabled SQL. Create also an entry. Okay, we select REST-enabled SQL as well, the reference to it. Let's say we select now the AMP table. We have all the columns, and it should be all fine. Right now, we go to the report. We see that we have it, but we don't need only this table. We need to perform a query, actually. So it automatically retrieves all the columns from the AMP table, and if we are going to join it with join with one of our tables, our local tables, like local department, let's put an alias in here, the on dot dip number and the dot dip number. Okay, just to be on the safe side and just maximize a bit this window. Okay, so we already have the error. It doesn't allow us to join. So
great. Thank you very much, Andrea. I think we're running really out of time. I have some questions here from the guys. Please. Let's try to answer very quickly. One of the guys saying, which are the security implications when using REST-enabled SQL compared to DB-Link? Are you aware of any?
Well, I'm aware for the fact that, let's say in REST-enabled SQL, as I said, you can use OAuth2 as the authentication method, so you get rid of the problem with passwords, and this is, I'd say, an extra layer of security. For DB-Links, this is pretty straightforward. There is a blog post around how to manage but autonomous databases, and there is a way that you can control who is going to have access to your instance, for example, because you can actually manage to retrieve only a list of APIs. An important thing to mention is that DB-Links, if you are dealing with DB-Links on autonomous, is that the target database, the one that you are building the database link on, should have a public API or a public hostname. This is a must.
Yeah. So do you think it's recommended to use basic authentication in production environment? Because there was a warning when you selected. So
no. So it was only for demo purposes. Okay. Yes, it is not recommended. No.
Okay.
That's why we have two options. Yeah.
And I think there was a question, when using REST-enabled SQL, which other restrictions, limitations exist apart from joins with the remote table? Any other
anything notable at this moment? No. for REST Enabled SQL. I'd say that for database links on Autonomous, there is a limitation right now because as you've seen, I've used SQL Developer Web, and I've created and granted privileges to my user in order to be able to create the DB link on that specific schema. Because let me go back to my demo. For example, if you are going to see Object Browser, we don't have any database links option here, so there is no wizard in Autonomous. So a better way to do it is through SQL Developer Web, and afterwards you can go only and query the table from the DB link. Let's say here. So Apex actually recognizes the DB link, but it doesn't provide you the opportunity to create it in Autonomous because from my understanding, they don't have the two PL SQL APIs embedded, and hopefully I'm not mistaken, the PL SQL APIs, DBMS Cloud and DBMS Cloud Admin. So if you are going to, let's say, okay, this is the DB link, and yeah, we have the data. So we can use DB links in Apex Autonomous.
Right. Actually, there are many other questions. Since we are running really out of time, we need to have 5 minutes break. We can answer those questions later. Please don't forget to provide your feedback, and I'm going to see you in almost 4 minutes. Thank you very much, Andreea, for your time.
Thank you very much, Salim. Yeah, thank you, everyone.